Hello? Okay, so at least we have one working here, but that means I keep standing here, which I don't like. Okay. That's interesting. So last time we stopped actually here. This is an interesting expression in C. We discussed if conditions, right? This is something that is very similar to the if condition, but it's done in a different way. Usually this kind of expression is found in low-level languages. Like if you try to do some kind of model checking or VHDL, Verilog, basically you will find this expression. This is nothing other than a conditional operator, which means you check a condition and you execute one of two expressions based on the value of this condition. So basically, you check condition. If it's true, then you execute the first expression. If it's false, then you execute the second one. It's like saying if condition, then expression 1, else expression 2, right? It's just a compact way of writing expressions in C. Something like saying, now you are assigning, the good thing here is also you can do some assignment, right? So now you are saying check if x is larger than y, then if that's true, take the min as y, otherwise the min will be x, right? If you translate this into if condition, if x is larger than y, then min equal y, else min equal x, right? And you can actually do this in long statements as well. So again, it's just a more of a compact way of writing an expression. Something that I said also in the loops case, like for while, do while. Usually in a language, especially if it's a rich language like C, you have different ways of doing things. That doesn't mean that one of them is correct one and the other one is wrong, right? It's basically you have different means to utilize, and then the more you get experience, you will learn what is the best expression to use in such use case you have. I give you some example in the for while case. I said for while actually are same expressible, which means actually any expression you can have in for, you can exactly do the same expression in while, right? But then these are different use cases. If you have a specific number of iterations, then for is the best to use here. If you have a condition that is not based on number of iterations, then you use while, right? Same thing here. If you have a long expression that is composed of multiple conditions, then this will not help you, right? Because this is used only to check one condition. Then maybe you need F or something else that we will see now, right? But if you have a very compact expression that only has two values, which is very common in programming, and you want to just write one line of code, then this is the one that is going to actually be more helpful to you, right? Good. Another thing that is important to note, remember that what we discussed right now in the past lecture is nothing new, except few things, but we go deeply in some of the tricks of the language of what we discussed, like if conditions, loops, and variable definitions, right? So one of these things that you need to know is actually, if you have multiple if else, then else is actually associated to the one that is previous to it directly, right? The one that is connected to it. What I mean by this is, here you have two ifs and one else, right? What do you think? Is this else is actually for this if or for this one? It may seem from the way it's written, it's actually for this if1. So if expression 1 is wrong, maybe you go to statement 2, right? But that's not true. And this is an important thing to know. The way you write things in your code, the way you organize things, using tabs, spaces, and these things, has nothing to do with the compiler at all. Actually, the C compiler ignores spaces and tabs and white space, right? So it has nothing to do with it. So the way you write it is not the way the compiler understands it. So actually this one is completely equivalent to this one. Why this is the case? Because when a compiler actually tries to compile an if statement, it keeps something open in its memory that says if you have a direct else afterwards, then this if statement has an else. If you went to another expression, that means this if is done, it doesn't have an else. Because you know in if statements you can have an else or maybe you don't have it, right? So the way compiler interprets it is basically, it combines the if statement, keeps something in its memory open to check if the next statement is else, then this is associated with this if. Otherwise, then you just close the if, go to another thing. So what happens here is, as a compiler, I check this if statement, for expression 1, and then I check the next statement. It's F. That means this one doesn't have an else, right? And then for this one, you do the same thing. The next statement is else. That means this else is associated to this one. This is why this expression or this block of code is totally equivalent to this one. Is that clear? This is very important because if you don't recognize this, then you have big problems. Again, a good programming skill is each time you have an if or else, even if you have one statement, make sure you use brackets or parentheses, right? This is actually very helpful because now you clearly identify what's going on. When you reread your code or you give it to someone to get graded or like you are doing a project or something, it's very easy to understand, right? Good. And then this is a different expression. If you want this else to be assigned to this one, then you put these brackets here, which means everything here is interpreted by the compiler as one statement, right? All of this is the body of F. Good? Okay. Two additional things we have in loops is the break and continue statement, right? How do we operate with this? Is basically, let's look into an example to make sure we understand this. So here we have two pieces of code, completely equivalent, except that we use a break statement here and a continue statement here, right? And then what we do in this code is basically we go through a loop, a while loop for 10 iterations. We increase, we check something, right? Whether your iteration is actually divisible by 3 or not. And then here, if it's not, then you break. And here you continue, and then you print something. Something I'd like you to do is actually spend the next 2-3 minutes, try to write these two blocks of code and see what is the difference. I'll give you 2-3 minutes for that. This is not a quiz. This is something that you just exercise through. You already have the code here, but I'd like you to see what is the difference. Why you guys are looking to me? Right? Just try to implement this thing, right? Because it shouldn't take you more than 2 minutes. Yeah, actually these two are not working. I was able to get this working, okay. But these two, I'm not sure if it's a battery issue or something.
It's usually batteries there, sorry they're not there. Somebody must have taken them.
Okay. I'm actually usually using this one, so if you're going to replace one, then maybe it will be sure thing. Thank you so much. Both are not, yeah, thank you so much. Okay. Was anyone able to get it working? Yeah? So what is the difference? Guys. Yeah. Good. And then what is the output? Good, thank you. Please give me your name after the lecture. Okay, so the difference between break and continue is basically for break, if the condition that you are checking is true, you entirely skip the loop, right? So you just go outside the loop completely. So in the first example here, basically the first iteration, I is equal to 1, you check, 1 is 1 dividable by 3, no. So basically this condition is not true, and then you print 1. In the second one, you print 2. In the third one, when you check, actually 3, mod 3 is 0, and then you break. Break means completely ignore the loop and then go outside, do something else. So you are done here, right? On the other hand, for continue, you skip only one iteration, the one that you are checking in. So what happens is you print 1, 2, the same thing, because the condition is still false. In the 3 case, you check, it's true, you continue, which means you don't print the 3 case, but what happens is you actually jump into the next iteration, where I is equal to 4, and then you continue, right? So for the continue statement, you skip only one iteration. For the break statement, you skip the whole loop and you go to the next block of code. Good? So another example would be here. You guys can try these things at home. Let's look into this one. Basically, I want to print certain numbers of stars on the screen. And the important thing that we want to get here is if you have a break or continue statement inside nested loops, right? What are nested loops? Basically, you have a loop inside a loop, right? So that means each iteration of the outer loop, you're going to execute the full number of iterations of the inner loop. So what would happen here is, in the outer loop, you have I going from 1 to 5. For each I, so for example, for I equal 1, you are going to do this loop for 10 times, right? So if we don't have break or continue statement, how many total number of iterations we have in either of these two examples? You have 5 outer iterations, and for each one of these you have 10 inner iterations. That means you have 50, right? Because you have 5 multiplied by 10, right? So we have a total of 50 iterations. What we do here is, for the outer loop, the only thing we do other than the inner loop is actually doing a print line, right? So if you think of this program, the outer loop is associated to print something on the screen in one line. And then in the next iteration, you go to the second line, right? And then within one line, you print something using the inner loop. Good? In this case, assume we don't have the break case here, right? Just forget about this break case and the if condition as a whole. What we do is, basically, because these are 10 iterations, that means in each line you are going to print 10 stars, right? From j equal 1 to 10, 10 stars, and then you do a printf new line, you go to next I iteration, you print 10 stars and do the same thing 5 times. That means you have 5 lines of something that is printed on the screen. You have 5 lines in the screen. Each one of them is composed of 10 stars, right? This is without the break or continue. In the break case, once you find that actually j is equal to I, you just break the loop, right? What I told you just 2 minutes ago is break is going to take you outside the loop, but which loop? This break is associated with the loop that is actually defined inside, which is the inner loop. So you only skip the for loop, but it's the inner one. The outer one is still in effect because it's not affected by the break, right? You only affect one loop by the break. What would happen here is in each line, if j is equal to I, you are going to skip this for loop and then you go to the outer one and you do the same thing. So basically what we do here is for I equal 1, j equal 1, you print 1 star. But then the interesting thing here is I equal 1, j equal 1, if you check the condition, they are equal. So you break, right? So you don't print anything in the case of 1, 1, right? And then you go to the second loop, which is 2. You check I equal 2, j equal 1. How many stars I'm going to print now? Is that confusing? So basically now what I'm discussing is I equal to j equal, and then the loop, going from 1 to 10, I guess. What would happen in this iteration? For the break case, I'm starting with j equal 1. Does j equal I? No. You print 1 asterisk or 1 star, and then you increase j. Now j equal 2. That means j equal I. So you skip, you don't print anything. You go to the new line, right? So this is j equal 2. I equal 2. Then here I equal 3. Can you imagine what would happen? You print in case of 1 and 2, but then you print the 3 case, right? And you keep doing the same thing. And then in case of 5, you only print until 4, right? This makes sense? In case of continue, it's different, right? Because, can someone imagine what would happen for the continue case? Yeah? Yeah, print 9 stars every line. And the reason for this is you skip to print only once in each loop, because it's guaranteed that for each inner loop, j will equal I at once, right? So that means you have 5 lines because of the I iterations, and each one of them is actually composed of 10 lines, right? 9 stars. Does this make sense? Is there any question on that? Yeah? Here, in this case? Yeah? So basically, what happens is you start from j equal 1 and you go to I minus 1 and then you stop. Because once you check j equal I, you break, right? So in the first time, I equal 1. That means you don't print anything. In I equal 2, you print only 1 star because you have only j equal 1, right? And then if I equals 3, you have 1 and 2. 4, you have 1, 2, 3. 5, you have 1, 2, 3, 4, right? So basically, this is what we had here. Just put into account that the first line here is completely, right? The confusing thing here. Is that clear? Okay. So you have this in the lab questions. Basically, what if you want to do multiple selections? If else would be completely okay to do that, and the way you do this is you do nested if else's, right? So assume, for example, if the score is larger than, this is a very common example of doing multiple selections when you do the grading thing, right? If the score is larger than 80, then it's done. You have A or excellent or something, right? Else, then you have a set of other choices. So now it's not one choice, you have multiples of these. You go through them one by one, and then you check the second thing is 70 and then 50, and afterwards you are screwed, right? Good. Then another thing that we can do, so another way of doing this is actually, instead of doing this if else thing one by one, something like this here, something to understand is this whole else thing, which is blue 80 up to whatever, like 0, are actually the else condition of the 80, right? But another way to write this thing, actually, you take it one by one. So we have what we call else if. So in if statement, we have if only, or if and else, or if, else if, and the last thing is else, right? So that means this full block of code is actually composed of one statement for the compiler, which is the if, and its alternatives, right? So you check if 80, if not, then you do this thing. That means each time you are actually, only one of these is satisfiable, right? Is that clear? So this is a different way of writing the code for the multiple selection. And then another thing that is also a different way of doing multiple selections, the switch statement, right? In switch statement, you have an expression or like a variable, and then it has different cases. For example, in case of grades, then you have the grade variable, and then it can have different cases like 80, like above 80, above 70, above 60, above 50, right? So the way you write this thing is you switch based on a variable or integer expression, and then you do multiple cases. At the end, you have the default statement, which is going to be executed only if none of these cases is applicable. Good? So let's take an example. Here, so basically you switch based on grade, right? And then grade, let's say grade is the A, B, C, D thing. So if grade is A, you print that you have something between 85 to 100, right? If grade is B, you do something, C the same thing, D the same thing, and then default statement. One question that I have is, why do we have the break statement here? Yeah? Exactly, because if you don't break, then what you are going to do is, case of A, you print something, but then you check this condition. Here what we have by default is actually if grade is only a character, it cannot be A and B on the same time, right? But if you go back to this previous example, a number can be actually larger than 70 and 80 on the same time, right? Do you see what I mean? So multiples of these conditions can be true on the same time. This example doesn't have this because it's either one of these characters, but if you have something like, this is above 80, and then above 70. If something that is above 80, it's by default above 70, right? So two conditions will apply. So if you don't break, you will actually do multiple of these statements on the same time, which is wrong. You want to execute only one case, not multiple cases. So you have to take care of this. Good. Yeah, another important thing to know is, and this is actually a very neat thing in C, is if you want something to be done, assume that I have multiple cases, like 5 cases. But it's not always that I want each case to be separate. Maybe in one of my code, I want to combine 2 cases together, right? Something or something, like case A or case B, right? You combine things together. For example, those who got actually grade A or B will do to a certain category, right? Or pass something, right? Or above a certain threshold. So then you can combine multiple cases and do one statement, glue them. Basically, what does that mean is here, case A and case A small is actually going to apply to either this or this. So if your grade is this or this statement will apply to both, right? So if you actually stack cases like this condition will apply to both of them. Make sense? One application to this is what we have here is if someone enters grade as like a capital letter or small letter, it shouldn't matter, right? You should take this into account from the user usability. And then you should apply this printf statement to both, right? If this is not clear, assume that I'm a user, I'm using this program, I enter A capital. What you'd expect as an output? Case A and case B, right? This would be your output. What if I enter A small? This also will be your output. Is that clear? Is there any question? Yeah? Only one of them, that's true. Because as a user, you only enter one of them. This is like saying this or this, that's true. Okay. So something that is mentioned here is this default statement. We don't have it here. We have a default statement here. Yeah, go ahead. Can you change the switch statement and the cases? This is a good question, right? So basically what you have in a switch statement, so the typical use case of a switch statement is actually not an expression, not a condition that you keep it changing. It's actually a variable that you are checking its time, right? So basically what I mean by this is, all the examples we have seen is you are either checking a numerical grade or like a letter grade, right? This is a variable that is fixed, right? You can still change this variable. Nothing will prevent you from this, but it will be very confusing. So from a syntax, to answer directly your question, from a syntax point of view or compiler point of view, this is true. It's possible to do that. But from a programming skill point of view or usability point of view, this is dangerous, right? Because now your condition is dependent on what is inside, and then if you change it, then your logic will change. How you would interpret or I interpret your code if you do that, right?
The follow-up question, if you change the case to one statement, you don't have a break after that, the next statement is the case that you just switched to the previous. Will it actually run the code from the next switch statement?
Okay, so to answer this question is basically, as a compiler, I don't understand anything. What I understand is you have a case statement, you have an expression to check. If the expression is true, then I do it. I have a break statement, then that means I don't check what is afterwards. If I don't have a break statement, then I check what is afterwards. So in your question, I don't have a break statement. I go to the second case, I check the expression. If it's true, then I execute it. I don't care about what you intended to do, right? Good. So we already covered these printf, scanf things. We have also other functions from the stdio.h where actually you can specify what you want to read from the screen. Printf would allow you to print anything. Scanf would allow you to actually read anything. It doesn't distinguish whether this is an integer or like a variable, or a character or a double or something, right? If I want to basically the user to enter a certain thing, like for example, a password that starts with a letter. You don't want this to be a number. You either do this checking yourself or you use some help from the built-in functions in the stdio.h. One of these functions is actually put character, get character. In put character, as you can see, put character is going to actually print a character on the screen. So it's a subset of what printf can do. Printf is the general case. You can print anything. Put character, you can only print one character on the screen. The same thing for get character. You can get, why this is good? Because in case of scanf, whatever is on the screen will be actually put into your variable. If you have an integer variable that you assign things to from scanf, then you will get an error because you cannot assign a character to an integer. Or maybe you can by taking the value, but let's say that if you don't have a type matching, then you have an error, right? But for get character, you are sure that you are constraining your user to just read a character, and you interpret this as a character. So even if the user enters one will be just as a character, right? Good. We already discussed conversion specifiers. So this is the general, we have seen this in multiple examples, but it's good to go through them. This is the general use of printf. Printf is a function. We will come to functions later, but basically what you need to know now, functions are taking input parameters, right? These parameters, the first one is what you want to print as a string, right? And then the remaining parameters are actually what is going to fill the placeholders in this string. So here, for example, we have sum equal a specifier or a placeholder, average equals something, and then that means now you need two extra variables, right? The first one here is going to go to the first placeholder, the second one is going to go to the second placeholder. That means printf is a flexible function that takes any number of arguments based on how many placeholders or specifiers you have here. Good? So what you expect from seeing this is sum equal 5 and average equal something of that sort, like 2.5, right? And this is why here is float and this is double. This is decimal integer value. Good. So another thing that you need to understand here is with these specifiers, so another thing that you can have here is this is not necessarily a variable, right? All the examples we have seen so far before this lecture, everything here was just a variable or a constant, like x, y, and then, or like a letter a, something of that sort. But in general, this can be an expression. The only condition we have here is that expression should evaluate to what this placeholder is referring to. For example, this should evaluate to an integer because you are expecting an integer here. This should evaluate to float or double because you are expecting a float or double here. Good? Okay. So this is formatted output. What about formatted input? Let's keep this one for now. For formatted input, you can do exactly the same thing. You are reading something from the user, but you want to place it in certain placeholders or certain variables. One example would be scanf, all these kind of things, and then you put into variables. What would happen is the first one, first of all, you should ask yourself how many placeholders you have. You have 1, 2, 3, 4. One of them is decimal integer value, one of them is long floating point, which is double, character, character. That means V1 will be an integer, V2 will be a float or double, here in this case is double, and then V3 and V4 are characters, right? Why do we have this AND here? Because we are reading the value, not the address. And let's say if I do this, and a user inputs this thing, can someone expect what V1, V2, V3, V4 would be? V1 would be? V1 would be, what is the value of V1? Okay, V2? Good. V3? GF. What about V4? 0. Good. What do you think? Good. So we have two opinions here. One of them is saying V3 is GF, while the other opinion is V3 is only G and V4 is F. Do we have other options? What do you think? Yeah? V3 would be G, V4 would be 0. Why 0? You have an F here. Yeah? Good. 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 So the correct answer is not here yet. So basically, is there any different opinions we have? Yeah? Would you please raise your voice? Okay. What would be V3? GF. So this is similar to the first opinion, but that's not true. So let's see here. V1 and V2 is actually very similar. Yeah. So V3 would be GF, this is what you're saying? F. V3 as F? As null, and like no one reads G, right? That's also not true. Good, so V1 and V2 is actually very simple, right? You enter two numbers and then this will be assigned to V1, V2. V3, you are expecting a character, right? Do you agree with me that white space is a character or not? White space is a character, right? So after reading this one, the cursor is actually, of the compiler is actually waiting here, right? You are expecting a character. What you find next is white space. White space is a character, it matches. That means V3 would be white space, right? And then what about V4? The cursor will move from white space into here. That means V4 will be G and F will not be read. Then an interesting question would be, if V3 would read the white space, why V2 didn't read the white space here? Because after reading the first variable, the cursor again is actually in front of a white space. Yeah? It's looking for a number, not a character, right? The problem that happened here is actually V3 is looking for a character, and then it matches the white space, because white space is a character. Good? Does this make sense? These are very important things to actually take care of when you deal with C tricks, yeah. New line is also a character, so that means it will be assigned to, yeah, it's a good question, or tab or anything. Basically anything that is a valid set of input for this specific variable or placeholder, then it's going to be read, right? Okay. Then what if I want actually V3 to be G and V4 to be F? I have to account for this in the scanf statement itself. So what I would do is, after the number here, I should put a white space. That means this is, I'm formatting my input, right? I'm saying I'm expecting a number, another floating point number, a white space, and then a character, and then a character. In this case, V3 would be G, and V4 would be F. The reason is I already accounted for the white space in my formatted input, right? I guess you guys dealt with this in Python by regular expressions, right? You have, like regular expressions are much richer than this, yeah.
If there was a space between 2% C, does that mean that V4 would be blank?
Would be a, yeah, a white space. Good. Okay. So how much time we have remaining? Okay, that's interesting. Each time we waste a few minutes for unexpected things. Anyway. So. Okay, so we'll continue doing some examples here, dealing with iterations and loops and conditions. One example we want to implement is actually read 15 floating point numbers input by the user and then print them in reverse order, which means if I enter 15 once, from 1 to 15, then you print them in the other order, which is like the last one first, right? One problem is with what we have right now, what we discussed in C, we cannot actually implement or like code this example, right? Can anyone think of a way that we can do this with the information we covered so far? We discussed variables, if statements, for loops, while loops, do while, printf, scanf, some functions, right? What I'm telling you is actually we cannot implement this in a good way using what we covered so far. Good? Can someone say why? Yeah? Why would I need an array? Yeah, and the reason for this is you want to store these 15 values, right? The difference between this example and the two examples we covered previously, which is the quiz and the example one, is previously we didn't need to keep the full set of inputs by the user, right? Now we need to keep this, otherwise we cannot go back and do them in the reverse order. We didn't cover so far how to keep large set of inputs, like more than one, and then deal with them, right? You can say I can define 15 variables, right? Good, but what about, I told you, you take like 1 million input from the user and bring them in the other side. You cannot do this in like 1 million variables, right? So you need an array. Good? So this is a good example of dealing with array. And this tells you something that is very good. Is actually loops in most use cases of programming are actually operating on arrays, right? Or some kind of a structure. The course you will take after this one is actually what's called data structures. We'll cover data structures later in the course, but we have algorithms and data structures. Remember the big picture we discussed? Guys. So we had the big picture of you have a problem, you want to actually code as an algorithm, right? And then you go through the full stack. Algorithms is a topic on its own, but most of the algorithms are based on what we call data structures. Arrays is one of them. Array actually is the simplest form of a data structure. So what we are going to do here is define an array, store the 15 variables in, and then bring them in the reverse order. Right? So let's see how we define an array and do these things. So first of all, what is an array? You already know this from Python, but as I usually do, I'd like you to basically understand the concept behind it. What happens behind the scene, right? If you define an array in C, you basically book a certain number, or let's say you book a certain storage in the memory that is contiguous in the memory. It's not distributed, it's basically contiguous starting from a certain address going to subsequent addresses. And then this is a predefined set of inputs, right? So what I mean by this is you define an array, let's say 5 variables, right? The first one will go to a certain address in the memory, assume this is address, I don't know, like FF, right? And assume these are integers, that means you need 4 bytes per variable, right? That means this will take 4 bytes, which is index 0, to the first one, and then 4 bytes, 2, 3, 4. And this will start from address 0, increment by 4, like this is the, assume this is the address of index 0, go by 4, by 4, by 4, by 4. Everything here is actually contiguous in the memory. That means it's one chunk, right? And this is one big limitation of arrays. Because if you don't have enough space that is contiguously free in the memory, then you cannot define your array, if it's large array. Good? So it's a big limitation, but also it's a big advantage from a performance point of view. The reason for this is because they are contiguous in memory. This is what happens in the hardware. They are actually easily accessible. Do you guys know what are caches in your laptops, right? You have caches, which means basically this is an intermediate memory that is very fast to access, usually in 1 to 10 cycles, instead of going to the off-chip memory. If you define such a big chunk and you access one of it, everything will be placed from the main memory into your cache. That means subsequent accesses are actually very fast. So arrays are very fast Arrays are very fast on access time, but the problem is they are limited, that they have to be contiguous in memory. Good? So the way you define this thing, as one example here, you define the type, here it's int, and then you define the name of the array, and then the limits of the array. In C, you cannot have a variable size array. It has to be static value. Again, why? Because you want, from the beginning, to reserve everything you need. Here you need to, how much storage you need from the memory. You have 5 integers, each one of them is 4 bytes. That means you are telling your hardware to reserve you 20 bytes of memory as a contiguous portion from the beginning, even if you didn't use these, right? This is why you need to define the limits from the beginning. Good. So these are some examples of defining an array. Here is an integer of 10 elements, double of 100 element. And to access a certain element or index in your array, you just type the array name and then the index itself. So to write our example, what we would do is basically you define these are 15. By talking, you are wasting more time actually. So it's the other way around. You just keep silent. Going to take only 1 minute because we have to finish this example, right? Good. So you need 15 floating point numbers, then you define a double array of 15, and then this I is for your iteration of the 15 loop. You need a loop because you need to tell the user to input 15 inputs each time you read one of them. We have done this before, so basically this is a loop of 15 elements. Inside this loop, you need the scanf to read the input, but what you do now, instead of storing this in a